Hello, welcome to another beautiful episode of the Weekend Algorithm. If you are coming across the Weekend Algorithm for the first time, this is what the Weekend Algorithm is really all about. It's about solving particular problems, coming up with algorithm that solves those problems in an efficient manner. Now, if you have been a viewer for a long time now, you know the drill. It's the problem, the algorithm, and then the solution. Now, today's problem has to do with archers. As you can see, we have archers on our screen. Now, they have targets, so also do I. Now, my first target for now is to get to 1,000 subscribers. And if you are yet to subscribe to this channel, please just to support the channel, subscribe, click that notification bell icon, and also give this video a thumbs up. Now, with that stated, let us look at the question for the day. So we take a look at the problem of the day. Right here as Hackerearth, it has to do with archery. Now, in archers are shooting arrows at targets. There are infinite targets numbered starting with 1. The ith archer shoots at all targets that are multiple of what ki, that is, there are multiple of its particular position. Find the smallest target that is hit by all archers. Now, our input format goes like this. The first line contains an integer t, which stands for the number of test cases. Now, these test cases follow. Each test case is of the following format. The first line contains a natural number n, number of archers. The second line contains n space-separated integers, where the ith integer denotes the value of ki for the ith archer. For each test case, print the smallest target that is hit by all archers on a new line. That would be our output. Now, the constraint is given. Our test case should not be more than 5 or less than 1. So it's between 1 and 5. And the number of archers given should not be more than 15 and should not be less than 1. And also, the maximum value of our k item should not be more than 48 and also not be less than 1. Now, our sample input goes like this. 1 is the number of test cases, 3 is the number of archers, and 2, 3, 4 are the position of this archer. So the sample output is 12. Now let us look at the explanation section of it. And the first archer shoots at target 2, 4, 6, 8, 10, 12. Now take note, it starts from 2 and the index of the first archer is 2. Let's just assume the particular value of the first archer is at position 2. So it shoots at target that are multiple of its value. So we have 2, 4, 6 all the way to 14. And for the second one, we have a value of 3. So it shoots at 3, 6, 9, and 12, so on and so forth. And the third one has 4. So it's 4, 8, 12, 16, and 20. So the smallest target at which all archers shoot is 12. So this brings us to a term in mathematics known as the lowest common multiple, which is the LCM. So this problem has been simplified to a mathematical form, which is the LCM. So that is what this particular problem is really all about. So with that stated, we have seen the problem. Now let us take a look at the algorithm to implement in order for us to come up with a solution that will perfectly solve this particular problem. So what we have here is the algorithm for the archery problem. Now we read the values from the input source and store inside of an array. This is pretty much after noting the number of test cases. After reading those other values, we just read the values from the input source and store inside of an array variable. That is for the archers. And we create and initialize the variable answer that will hold the value of the final GCD that is run. It should be LCM, which is lowest common multiple. So just let me correct that. Now we create and initialize the variable count to keep record of how many times a particular divisible can be divided with the array. In addition to that, I'm creating a method, a function which I call simplify, that computes the number of times it takes for the values in the array to be divided by 2 until there is not a number that is divisible by 2 in the array. We compute the power of 2 to the value returned by the function called simplify 2. So this is a function I will be calling in our code. Now we add the resulting value to the variable answer that was previously initialized. We repeat step 4 to 6 above for 3 and 5 respectively. So when we calculate for the LCM of a number, we use 2, 3 and 5 at first to make sure that we have successfully divided all the number with the very base and prime numbers, which are 2, 3 and 5. And we take the new values in the array and place inside an object of type hash set in order to remove duplicate numbers. We will also be looking at this in the code when we look at our own implementation of the algorithm. I will multiply all the values in the hash set and add the value to the variable answer that was stated above, and that will be our final LCM, which is the lowest common multiple. And let us take a look at the algorithm for simplify. So here's the algorithm for the simplify function. At first, we initialize the value of count to be returned. We create a variable called is divisible. Now do the following where is divisible is true. Update the value of is divisible to false. For each number in the array, if the number is divisible by the divisor and is divisible is equal to false, then do the following. Update the value at that index to its initial value divided by the divisor, add 1 to the value of count and set its divisor to true. Yes, if the number is divisible by divisor, update the value at that index to its initial value divided by the divisor also. And at the end of the day, we return the value of count. So that brings us to the algorithm, to the end of the algorithm part. Now let us look at the implementation in IntelliJ. So right here we have the code to the problem, the code that pretty much solves the problem, and this is an implementation of the algorithm we just looked at. Now we have static int numbers, so I'm using static feed for the problem. So we have static int numbers that represent the numbers of archers, and we want to simplify the numbers. So we have the simplify method that takes in an integer which stands for the divisor. Let us pretty much take a look at our main method. So we read the number of test cases, and while test cases is still greater than 0, we read the length, which is the next value on the input source. Then from there we take a look at the different index number of the array and so take those numbers, use the array.string to divide those numbers and store in our numbers variable, which has been defined initially from the start. This is it. And the next is to initialize our answer, and I'm using a long variable and I'm calling it a common multiple. So this is pretty much the common multiple of all the values. So we have math.power 2 at first and simplify 2. So simplify 2 is a function, and that function is above. We're looking at the function in a bit. So we also call for 3 and we also call for 5. Now we take the remaining values after performing the simplify operation on the numbers, and we use an hash set to remove duplicates, and these duplicates are pretty much the values that are not divisible by 2, but we want to make sure we are removing them from the remaining number array. And for each of the distinct numbers, we want to multiply them by a common multiple and add it to the common multiple. So that is what this particular statement here is doing. Common multiple is equal to common multiple multiplied by the particular value at that index. So I'm using a for each loop at this point. Now at the end of the day, we print out the common multiple and we reduce the number of test cases to check the next word test. So that is it. Now let us take a look at the simplify function. It's straightforward. This is the int count. This is the number it returns. So int length is equal to numbers.length, and we check boolean is divisible at first. We just define the variable, and inside of our do loop, we are going to initialize divisible to what false. Using a for loop, we are going to check if numbers at a particular index is divisible by the divisor and is divisible is false. We just have to make is divisible true, update the value of that particular index to its initial value divided by the divisor, and then we increase the number of counts. So the reason for is divisible here is due to the fact that we are not just dividing just one number by the divisor for each numbers in the array. So is divisible is going to make sure that we only increase the value of count once for every division that goes through for that particular divisor. In case we've increased it before, we don't have to increase the value of count again until it has finished dividing all the numbers in the array and dividing it again for the second time. So why is divisible is true, so we have it here. It should continue with the do loop. Now at the end of the day, we return the count. So that brings us to the end of the algorithm part. And let us take the whole of our code and test it in the code editor right at Hackerearth. So for that, I'll just Ctrl A and Ctrl C. Then we'll move over to Hackerearth. So we have gotten to the final part of the series, which is pretty much the best part of the series. Now we are going to test our code. So for that, I'll change the C compiler to Java, and then I'll copy the whole of this, highlight them and paste my code. Then at first we want to compile and test to make sure our code passes through the first test case. Okay, sample test case passed, and next is to submit the code. So I'm submitting, and I have to point something out. This particular solution I just brought is a solution that only works for the given constraint. What we as programmers and software engineers try to do is come up with a solution that is much more efficient on a large run for even cases that are above given constraints. So I want you to take it as a task upon yourself to also look for a particular solution. Just there are some tweaks you make to my code and you can get that solution for values that are above 15 and for values that are above 48. So pretty much in the next episode of this weekend algorithm, we'll be looking at a solution that solves that efficiently. So I want you to stick around so you see how I've implemented that particular solution. So that brings us to now to the end. There's this something. So this is the final solution. The test case is accepted and all of these test cases passed. So that brings us to the end of this week's algorithm. So like I stated from the beginning, if you are yet to subscribe to this channel, please do so. Give this video a thumbs up and also ping that bell icon. And you can also share this video amongst your peers. Thanks, peace out, see you in the next one.